Hello, everyone. Thanks for coming. I appreciate you having the very nice weather this week for my first visit to Sydney. Thanks a lot. My name is Jimmy. You can find me at Twitter at @jbogard, and I promise it's not entirely untapped check-ins. There are some insightful tweets somewhere in there. And you can find me at GitHub, too, at github.com/jbogard. Pretty much everything I do is on that repository, including every presentation I do. So if you check that out, you'll find all the materials for this as well. And I blog at Los Techies, so you can go to jimmybogard.lostechies.com. And I work at Headspring, a consulting company in Texas, very far away from here, very, very far away. And most people know me because I work on an open source project called AutoMapper, which we may or may not be talking about today. We'll see. So today I want to talk about the new ASP.NET Core framework, which is released, right? It's not Preview 2, Beta 7, SDK something. It's actually out now, so that's good. I want to talk about a little bit how we build ASP.NET Core applications. And one of the interesting things about the ASP.NET Core framework, besides a ground-up rewrite, is just like the old ASP.NET framework, MVC and Web API, is completely devoid of any opinions about how you should build ASP.NET applications. So what I wanted to do with this one is take kind of the normal ASP.NET Core application you typically see out in the wild and wanted to refactor it to make it more solid. Solid being the single responsibility principle, the open-close principle, something about inheritance, interface segregation principle, and then the dependency inversion principle, although some people just say dependency injection and just be done with it. I actually don't have very many slides. This is like the main one that we're going to go straight to code. So let's just do that. Sound good? OK, so enough of that. And now we'll be using Visual Studio. I'm not one of those jokers that says they code in Visual Studio Code or something like that. I'm using a real editor here. OK, the first thing I wanted to do is just go through this controller and view as it is to just kind of see what we see and see if there's things that stick out to us as things we want to try to fix or remove some of the duplication, make it more solid. So this is kind of a normal MVC-style controller. It's got a number of actions as part of it. So there's an index action, a details action, a create action with a lot of space there, need some space. And then the normal kind of top-level things you typically see. So create, edit, update, delete. And I wanted to take a little tour of these to see what kind of things we see stick out to us in terms of duplication and the stuff that just we see over and over in our typical applications. And just to make sure that this is a real running application, I'm going to run it and make sure it actually works. So it does actually have a real database behind the scenes. In this case, I'm just showing a list of students, nothing terribly exciting, except that I can do things like edit them. So I can go edit them and add some additional information here, save. And yes, indeed, it actually saved. I can create a new student. How about me? And my enrollment dates, I don't know. Today, why not? And then we would verify, yes, indeed, it actually did create me up there. So yes, this is a real application with a real database underneath the covers. So it probably looks and feels more like the applications I typically write. So let's look at this controller here. Now, most applications I run into, the MVC applications, have two general flavors of actions. There are my get actions, and there are my post actions. The get actions are going to be making some sort of query and showing some data on the screen. And then my post actions, of course, are going to be manipulating some information behind the covers. OK, so here's our index action. It's somewhat complicated because it's having to do sorting, filtering, pagination as well. So my controller is building up a result object that it passes along to the view. It takes in a query here. So these are the query string parameters. And after some code here, falling down at the bottom, here we go. It's building out my view model in the form of a page list that it passes along to the view. So far, so good? And then inside my view, it's nothing exciting here. It's just building a table of entries down here, and then displaying that information on the screen. Not that exciting there as well. So my get actions more or less look the same. There's may or may not be some sort of input for query string parameters, and then it builds out some sort of output. Now, every application that I build as well is going to have one single model in and one single model out. And one of the reasons I do this is on the model in side, this is a lot more refactoring friendly. So if I add additional query string parameters, it doesn't necessarily break other parts of my application that assume a very specific ordering or naming of those parameters as well. So these are all the query string parameters that could potentially come in as part of making that individual request. One of the other first things you should notice as well is that out of the box, I do have dependencies being injected into my application. So in this case, that school context, the DB context from Entity Framework, that's being injected, this time by not by my own dependency injection container, but actually from the one out of the box from ASP.NET MVC Core. That piece is actually set up in our startup over here, and then a little bit further down, here we go. So that right there is manipulating the base service collection. You can think that as the thing I stick all my services into. And I'm telling it to add this DB context of type school context with some configuration saying, I want you to use SQL Server, and the connection string is going to be what I pull from over here, this default connection from the configuration manager here. So that kind of checks the D off the list of my solid out of the box. In older versions of MVC Framework, it was pretty annoying to have to deal with dependency injection. It wasn't out of the box built in, and you usually had to poke many different places to make sure your dependencies got absolutely everywhere. And we'll see with some of the other extension points here later in MVC that everything in MVC Core is dependency injection enabled. So I can take those dependencies with just about everything I use inside of MVC Core, including my controller here. So D is down. Now we can focus on the solid part of the solid. All right, so let's look further down now at our different controller actions. Specifically, I want to look at the form posts. So I'm going to look at the create action here, okay, and then the edit action down here, the two form posts. Now, if I look at these two controller actions, I see some commonalities here. That my form post will typically take the form of doing some sort of model state validation. So validation has already occurred. Let's say, OK, is it valid or not? And if it is valid, then let's actually do the work of the controller action. We'll save some changes, and then finally redirect. And if it wasn't valid, then I go ahead and show the view passing in that model so they can get rehydrated. Now, nearly every single one of my post actions looks exactly like this. Do a model state check, do the actual real meat of the work, save changes, and then go redirect. Now, one of the duplications I typically see in my applications, and not the kind of copy-paste variety where it's the same exact code in two places, but it's more of a concept duplication. And the concept I see here, the overall kind of pattern I have, is doing a validation check, doing some work, and then saving some changes. So what I'd like to do is take advantage of some of the extensions in MVC Core to remove this duplication I see in all of my post actions. So first, what the one I want to get rid of is this right here, db.savechanges. That's the line of code that is something you can't ever really forget to do. If you forget to call save changes, then your changes aren't flushed to the database, and then you'll just have some, like, oh, you edited something and nothing actually changed behind the scenes. And in my applications, if I have to remember to do something, then I'm probably going to forget, even if it's something as simple as calling save changes. So what I want to do is build a policy in MVC Core so that on every single request, my changes are always saved to the database, and I never have to remember to call save changes ever again. So let's do that. By the way, one of the other things that you can look at to see, am I violating solid, is if you go up to the top and look at your using statements, and if you see things from a lot of different places, things like I've got things doing with MVC, I've got link, and there's Entity Framework in there as well. If I see a lot of different concerns in one single spot, it usually comes out in the form of my using statements. But back to our save changes. What I want to do is take this and put it into a place in the MVC core pipeline so that it executes on every single request. Now, similar to ASP.NET MVC and Web API before it, MVC core has the concept of filters. And filters are sets of code you can execute before and after every single request at specific parts in the execution pipeline so that every single time it happens on every single request. And what that allows me to do is that this kind of duplication that I copy and paste in every single one of my actions, I can pull that out and have that in one single spot as in the form of just one single class that then goes across my entire application. So let's do that. Now, I've also got some cheat code here, so I don't want to mistype something. So I actually got it over here in the form of a filter. And the other thing I want to do is go into my DB context and add a bit of code there. And I'm going back to my cheat code here to grab that. Here we go. So one of the kind of interesting things about Entity Framework, both in Entity Framework and Entity Framework Core, is they try to hide a lot of the transaction support behind the scenes. I don't really like that. I like to be very explicit about when a transaction begins and when a transaction ends, as opposed to just kind of a magical save changes call of like, well, where did the connection open? Where did the transaction open? Is there one transaction that I do up here and another one down here? I don't like that. I like to have a very explicit boundary. So I'm going to create that boundary by extending my DB context a little bit here. So let's go to my school context. And I'm going to add, this is my DB context that I'm using for the entire application. I'm going to add a few methods to help me build out some transaction support. So I'm exposing a few methods here. One is to begin a transaction, and that'll open up a transaction behind the scenes down here. One of the other things I like to do is to have a very explicit isolation level in which I'm opening up the transaction. Does anyone know what the default SQL Server transaction isolation level is? Serializable, that's wrong. It actually depends on the version of SQL Server you're using. Like even different editions of SQL Server will be like read committed, serializable. I think snapshot may be a default here pretty soon. It's really all over the place. So instead of me relying on the installed database default or someone's default that some DBA put somewhere, I want to be very explicit about that. And that's what I'm doing here is being very, very explicit about saying I'm opening a transaction with this specific isolation level. Now, one thing you could do that I do in some projects is open up different isolation levels depending on whether doing a get or a post. Like you could do a read uncommitted for a get versus like a snapshot for posts. That way you have just different concurrency models based on the activities you're trying to perform. I'm not going to get that complicated. I'm just going to have begin transaction with this specific isolation level. And luckily, I'm using Entity Framework Core. Luckily, it's actually exposed. It's kind of a crapshoot with Entity Framework Core these days about what it actually has out of the box. It's 1.0, but I think that's a kind of a loose term with that release. I'm also going to expose some methods to close the transaction. If there's an exception, it'll roll back the transaction. Otherwise, it'll go ahead and commit the transaction. So all that stuff that people typically build into like a unit of work class or something like that, I like to just stick that right on the DB context itself as opposed to building some other abstraction. One of the things I want to highlight here is that the solid principles don't mean abstract everything. It just means put things in the right place, and that's what I'm trying to do here. OK, so back to our filter. I declare this MVC transaction filter to be an async action filter. This didn't exist in previous version of MVC. There was no async. So the MVC core pipeline was completely rehauled to be async all the way, just like you saw in Web API if you have seen that as well. This filter can now take up a dependency. OK, so this used to be super, super hard to do in ASP.NET MVC, the previous version. You couldn't actually have a filter take dependencies at all. You'd have to do like service location or put it in a very special place. Or I've seen tricks like put it in HTTP context items. Anyone ever do that? Yes, that's like the thing that exists in every single request. You can stick stuff in there and have it available for parts later on the request, but that seemed kind of crazy. Interesting thing on filters with previous version of MVC is they were all singleton. So they were instantiated once for the entire lifetime of the application, and there was that letdown feeling when you realize what it was doing, like, oh crap, I'm going to have to code around this. Well, that's not happening anymore. MVC Core is building out the concept of a composition root so that I can have one single spot where I instantiate everything for the entire request, and depending on lifecycle rules, we'll have things instantiated at different points. So what that means for me is that my filter can now take a dependency on a DB context. Now, on the actual filter method itself, the onActionExecution async, which I don't know what that means in real English, but I think it's just when the action executes. There's kind of weird naming syntax on their different methods here. So this means when the action is executing, do the stuff. And what it does is it passes in this delegate, which is supposed to be the next thing to do. So my filter, let's see if I can get it all on the screen here. Here we go. Has a try-catch. It's going to first await against opening the transaction with a begin transaction method. Then it's going to call await next. And that next is the next thing in the MVC pipeline. So it may be another filter. It may be executing the action. That's all encapsulated for me in terms of my individual filter here. I don't care. It's just the next thing to do. After that next thing is done, then I go ahead and close the transaction. That would commit the transaction. And if any exception occurs, then I'll go ahead and roll back by passing in that exception. I'm seeing this now, and I probably should have named those like commit and rollback, but hindsight is 2020. We'll edit that out later, I'm sure. OK, so now that I've declared my filter, I can then go register that in part of my startup. So something else new in ASP.NET MVC Core are the ability to configure it directly using this configure services. In previous versions of MVC, you had all these static classes you were dealing with, like the bundle config, the filter config, all those config classes. Remember those things? We don't have those anymore. Now you have a single spot where you can specify all your MVC Core configuration. And that's what I'm going to do right here. So I'll do my little configuration block, and I'll say config.filters.add. And I can tell it the type of filter I want to add. So in this case, it's going to be type of MVC transaction filter, that one. Now, because I'm giving it the filter type and not a filter instance, MVC knows that it needs to instantiate that filter every single time for each request. That's what I want. OK. So now with that filter in place, I can go back to my controller and remove some of these save changes. So in my post actions, create, save changes, goodbye. Edit, save changes, goodbye. And delete, save changes, goodbye as well. So what I've just done there is removed some of the responsibilities from my controller of knowing when to call save changes and commit those to the database. I've removed those and put it in one single class. So that's the S in Solid for having a single responsibility for managing the transaction scope for my application. Oh, but let's make sure it actually works. OK, so I should be able to edit my information. And it should save correctly. And yes, it did. So hooray. Now, this is just one controller, I know. But if I have my typical application that I'm working with has dozens of controllers. Some of the applications I work with have over 100. And if I have to have that one single line of code in every single controller action, that's just going to bloat up my code. And if I ever need to change what actually goes on behind the scenes, I'll have to go fix that in all those different places. So let's say you need to have a policy around saving changes to do something like logging and logging when something fails, something like that. Well, now I have that one spot I can go to be able to have that sort of logic. Some people don't like this because they're like, it's magic because save changes, I don't know where it's being called. But that's like 30 seconds of conversation to clear that up, or documentation somewhere maybe, and you don't have to worry about that sort of conversation really ever again. OK, on to the next. So I remove save changes from each of those. Now the next thing I see is this if model state is valid on both of my controller actions. This is the one that I really do get annoyed with, just seeing that if model state is valid over and over and over and over and over again. It just gets really annoying to have to deal with those happy path, sad path for every single form post in my system. One of the other things that can be pretty difficult to deal with in form posts is if the model state is invalid and there was some validation error, now I got to worry about how to display those errors to the end user. And here I'm just taking the model that I was passed in from the form post and straight up passing it on through the model that I'm showing on the view. But that's not necessarily the same model that I was originally hydrating over here when I was showing the form to begin with. And so if you're familiar with MVC applications and you built a few of these, you probably have some code in some of your form posts that's like, OK, here's the actual form post model. Let me go also hydrate some other junk in there because not all the information was posted up. So you have something that's like, OK, I got the model, then go rehydrate some of that additional junk and go on from there. Well, I don't like doing that on all my form posts. So what I'd like to do is do something I did with the transaction filter and try to get and remove all of my model state valid checks throughout the rest of my system. To do so is going to take a little bit of finagling, unfortunately. So I actually have a diagram of what this looks like. So if I look at a normal validation flow in an application, the normal post redirect get, we'll do a post to the MVC controller. It'll check to see if it's valid or not. And if it's invalid, it'll return the entire HTML payload rehydrated with my view model back to the end user. If it is valid, then I go ahead and do the work, save the changes to the database, and then I return that redirect to the end user so they can go see the changes that have been persisted. So the post redirect get. The problem area was this part right here. I'm returning back all the HTML to the end user, and they have to go then, I have to make sure that it can properly show that HTML based on just the form data that was posted up through that post flow. So I'm going to flip this. In my modified validation flow, and this is a trick I've been using for about 4 years or so, my modified validation flow is going to hijack the form post. And instead of doing like a sort of full post, it just takes the form variables and posts them up to my controller. My controller will check to see if it's valid. And this time, instead of passing back HTML of like the full form and all the validation errors pre-rendered, I'm only returning back the error information in the form of a JSON object. The JSON object will have which properties are invalid and also the validation messages for those invalid properties. Then on the client side, I'll have to take that and bind them up to the screen somehow. And if you're using a client-side application framework, so if you're using like React or Angular, or if you're one of those guys using Aurelia out there, then all of this sort of stuff will be more or less taken care of for you, minus the server-side hookup of getting the validation errors back to you to be able to be shown for you. Otherwise, on the success path, I want it to be exactly the same. So what I want to do is hijack my form post, make an AJAX call. On the server side, I'll just check to see if model state is valid. And if model state is invalid, instead of returning back HTML in the form of the view, I'll actually just return back the errors to the client, and they can then just rebind them to the screen. So let's do that. First, let's look at my filter that's going to be doing the server-side validation work. OK, so this is my validator action filter. And I don't really care what validation framework you're using. This works for all of them, really. And really what I'm trying to do here is encapsulate that flow of if model state is valid, then do the success path. If model state is invalid, then do the sad path. I want to have that in exactly one class in my application. So in my validator action filter, which is an I action filter, the onExecuting method means it happens before or during. I don't know. The naming is really weird here. In this part, I'll check to see if my model state is valid. If it's not valid, then what I'll do is just straight up serialize the model state, that's the underlying validation information inside MVC core, and then just serialize that whole object as JSON. So I'm not creating some sort of intermediate validation object. I'm just saying, take whatever MVC has and just shove it onto the client, and I'll go deal with it over there. So finally, yep, here we go. So the filter context, I'll set the status code to 400, and then I'll set the result, this content result, over to the filter context. Now, when I replace the result on the filter context object, that means it's going to do that result as opposed to continue on with the controller action. So this means that my controller actions will no longer have to deal with the sad path of validation. OK, now that I have the nothing afterwards. So now that I have the action filter defined, I want to register its startup. So over here, I will go ahead and do config.filters.add type of validator action filter. And then finally, there's a bit of kind of ugly code, and this is not, it's not ugly because the code is all that ugly. It's just because I'm not really that much of a front-end developer, so this is as much as I could manage given my limited front-end skills. So what the front-end set of code is going to do is hijack the form post and then take that model state errors and then just put them on the screen next to the right HTML elements based on where the input elements validation error should be. I'm going to just shove that over here in my layout. Right. That looks like a good spot. OK. So I won't go through the whole thing, just this one little part here using jQuery. It's going to hijack every form post form. And on submit, it is going to serialize the form data right here. Going to remove any validation errors that may already exist on the screen. And then perform this AJAX request. It's going to do an AJAX request against the existing URL, the action for that form, and post up the form data as part of the data it's going to post. And then on success, it's going to do this right here. And on error, it'll go ahead and highlight the errors. Now, I won't go into the highlight errors function. It's just like Lodash code that loops through all the errors and highlights the correct things on the screen. Not very exciting, mainly because I don't find JavaScript code that exciting. But it works. All right. So with that front-end code there and my back-end filter, I can now go back to my controller and just remove all these really irritating if model state is valid checks. OK, so let's find it. So this is a get action. It won't have one. Get action won't have one. Get action won't have one. Here's a post. OK, so let's just go ahead and remove that and remove that. All right. And in my edit action, I'll remove that and remove that. Lovely. All right, let's run this and see what we see. All right. So on my edit action, I'm just going to do the happy path and make sure it actually works. I'll remove that. I'll hit save. And it broke. Sometimes I forget to pull in some jQuery here. I told you I was bad at front-end JavaScript. All right, well, I'll come back to this later because I don't want to spend too much time on this, other than this works when it works. When it doesn't work, well, then you have to get your front-end developer to come show you what's wrong with it, probably going through like Chrome DevTools or something like that. So what I'll do is I'll go ahead and remove that and just say it works, and the demo that I post up later will have the correct code. Sound good? All right. There's a question, yes. All right, so the question is, we'll be covering server-side validation. So I guess I should have pointed out, this is still doing server-side validation. The only thing I'm... Oh, so what if my validation has to do something a little bit different, like hit the database or something like that? If I need to do that, I won't use the MVC core validation stuff, because I find it to be not that great. And instead I use Fluent validation, which actually is dependency injection aware. I won't go through all that because that's like a whole talk onto itself to go through Fluent validation, but I would check that out because your validation classes in Fluent validation could be registered with dependency injection, so they can take things like a DB context to do that database level check. So in my applications, I typically have two levels of validation. One is the just really simple form validation, like is this thing required or not? And then the complex business level validation, I use Fluent validation to do that. Good question, though. Like I said, we're just going to pretend it works and not show any more validation errors. And I will take out this probably really ugly JavaScript code and fix it on the example I'll post online later. OK. So going back to my controller, one of the other things I wanted to do was introduce AutoMapper as a way to get rid of this dumb left-hand side, right-hand side code. Now, does anyone here use AutoMapper? OK, everybody. Yeah, so one of the things I wanted to highlight are some of the features that are kind of lesser known to people in AutoMapper land that I think are really cool. So what I want to do is get rid of all of these, but what I don't want to do is do the old AutoMapper way of doing things, of loading all the properties into my domain model and then mapping my domain model into my view model. I'm going to be using something else entirely. Now, what I've already done is in my project JSON, I've already referenced AutoMapper as a dependency using the latest version on the mygit because that's how I roll. Something I am adding on top of this are some extensions for Microsoft's dependency injection framework. So this automapper.extensions.microsoft.dependency injection, that's a new package that plugs in AutoMapper with the dependency injection container that ASP.NET Core uses. Now, why is that important? Well, if I go back to my startup, we'll have a very similar feel where I can do services.add AutoMapper. There we are. So what that's done, let me add one more thing here, type of startup. So what that's done behind the scenes is for these different types I've passed in, it's going to be using reflection to load up all the types to see if they have any AutoMapper configuration defined in that assembly. And if it does find it, it's going to pass that in into the AutoMapper initialization. So that's equivalent to me doing something like mapper.initialize and then adding all the profiles, add profile, and then all the profiles in my application. So I used to accomplish this, find all the AutoMapper configuration via dependency injection, and then people would do really horrible things like having their profile configuration take dependencies on like DB context and like hit the database during configuration time, which was a really, really horrible idea. But it was enabled because that was all configured through dependency injection. So I'm not doing that. Instead, I just call add AutoMapper, and any profiles I have defined in these assemblies that are in that type will just be automatically loaded up and initialized with AutoMapper. So let's go over to our view models and add in all the appropriate AutoMapper configuration we're interested in. So I'll just call this student profile. It's going to hear from profile from AutoMapper. And some of the maps I'm interested in are going to be, let's go to our controller. First of all, we see in our index action, here we are, this select projection here. So I'll need a map from student to student index model. Student index model, there we are. And probably one for details as well, for student to student details. And probably edit as well. And probably delete as well. Okay, so with all the mapper configuration, oh, there's a couple more. I'm going to cheat. I don't normally do this, but the edit action and the create action are doing really very boring backwards mapping code, like really simple ones. So I usually don't recommend people to do this, but because this is a demo, I can cheat. I'm going to go ahead and reverse map these two pieces as well. Oh, just the edit one, and then finally I'm going to create a map from student create model into student. Okay. I never do that in actual production application, but this is a simple one, so I can cheat. Okay, so that's all the AutoMapper configuration I need. The next thing is to go back through my controller and then replace all that mapping code with the AutoMapper code instead. Now, the ones that are going through DB context to use this select like this, I can replace this with project to student index model. And this is defined in AutoMapper queryable extensions. And what that project to is doing is examining the source type and the destination type, so student and student index model, loading up the AutoMapper configuration for that mapping, and then building out this exact select expression that the configuration represents. Now what's interesting about that is the Entity Framework Link Query Provider interprets that select expression and builds out the exact SQL I need to be able to hydrate that view model. So that means I don't actually go from database to domain model to view model. I go straight from database to view model directly. So goodbye that. And down here, the same thing. That whole block of code right there can just be project to student details model. So it handles top-level properties like this. It also handles sub-collections. So this enrollment select. And also handles flattening. So this course.title, it handles that as well. So I can get rid of all of that junk. Goodbye. Other really cool thing is when you use select projections in ORMs, you don't have to do any of that include junk you normally see. So this kind of like dot include, does that not exist in any framework core? Oh my goodness. Maybe it's over here. Intersect. There's no way it doesn't exist. I know I've seen that before. Maybe it's not called include. I'm not an Entity Framework core person because it's not a 1.0 product. It's a 0.1 product. Our applications that use ASP.NET Core run on full .NET Framework and use like the real NuGet packages that actually do work for the real world. So you can still use ASP.NET Core on full .NET Framework, full other packages. That's the way that our clients use them right now. Okay, let's keep going. This one, this is mapping a student create model into a student. So let's just call mapper.map. Yes, pull that in. Student create model to student. Passing in the model. And that's going to return a student. So this replaces all of that. Oh, another projection I can get rid of. So dot project to student edit model. getting rid of all this stuff. And on the reverse side, the same thing. I'll map back into that original student. So mapper.map, student edit model to student, passing in the model and the student. So I'm hydrating an existing object, not mucking around with the existing properties that are in there. Actually, that's redundant. I don't even need that. There we go. So map the model into the student. And finally, I believe the delete action has one as well. Oh, here we go. Dot project to student delete model. There we go. My favorite part of my job, deleting code. All right, so I've replaced all of the manual projections with AutoMapper-based projections. Now, the configuration was very simple here. I would caution that if you find yourself having more mapper configuration than auto-mapped members, probably shouldn't use AutoMapper, probably just map it manually yourself. So if I find it getting any more complicated than sort of like redirecting members and some calculated members, I don't tend to use AutoMapper. I just go ahead and manually do it. But this being a dummy application, I can do whatever I want, including making the mapping as simple as possible. So AutoMapper configuration is there. I've replaced all my projections with AutoMapper projections, whether in memory or through link. And then I've also registered AutoMapper over here so that I can use it throughout the rest of my application. So with all that in place, let's make sure it actually works. All right. Let's go back, just refresh this page, make sure it's all, yep, looks like it's all working still. I can still edit things, right? Edit, yep, save it. Yep, I fixed the validation thing, so that's working now. Details, oop, it says I'm missing a map from enrollment to that one. Oh, that's right. Some people do this. They do mapper.assert configuration is valid during your application. So if I did that, I would probably get that error saying I'm missing something. Oop, there we go. Unmapped members found. On the student create model to students, I have some unmapped properties here. So let's go fix those. Oh, right. Student create model to students, yes. Okay, so back in my models, student create model to students. By default, AutoMapper assumes that everything on the destination type should be mapped. It usually thinks I'm projecting. In this case, it's not. It's everything on the source type. So for this one, I'm just going to configure AutoMapper to say, just ignore and map everything from actually the source members. And so during configuration validation, instead of paying attention to the destination members, pay attention to the source members. So the question, is that new? Relatively speaking, yes. So like 4 time frame. Oh, still got a problem. Different one though. The enrollment cannot be mapped. So there's not a map from student details enrollment. It'd be really cool if the exception message actually had the configuration so you could just copy paste. I'm just making a mental note here. Okay, so let's go ahead and add that configuration as well. So that said student details model. So there was something about student details model dot, oh, that's right, that showed the collection. So enrollment to student details enrollment. Oh, okay, so the configuration validation worked. And the detail, there we go, details works. So through link projection, it was able to hydrate the top level model as well as a collection of items as well. So even though I'm using Entity Framework Core, it still supports some pretty complex operations. It's able to support like a one-to-many joined up set of data behind the scenes. Now if I had SQL Profiler open, I could show you the exact query that's being run to prove to you, but the queries generated from Entity Framework are so ugly, we don't want to look at them, so let's not. Okay. So I could go further with controllers, and I usually do. I usually go through and take all of the actual business logic that's happening and put those into individual classes by themselves. I'm going to go through all that practice. If you want to look at the full, there's an entire talk dedicated to even taking controls further down the path. But now I want to switch gears and now take a look at my views. So up to this point, I've been mainly focused on the controller part of my application. But in my systems, the views have just as much duplication as the rest of my application. And people tend to ignore that the view is just about rendering HTML. How crazy can it get? Well, it can get pretty crazy. But what I found is that the abstractions actually available in both the old MVC and the new MVC core are not really well equipped to handle the kind of duplication I see on my projects. So I tend to build enterprise-y applications, maybe that's a bad word, line of business kind of applications that are a lot of forms of information, a lot of tables of information, and people are using this application on a daily basis to do their jobs. Not so much like a public-facing web application. It's more like a behind-the-scenes back-office application. And for those kind of systems, I'll have applications with 100 or so controllers and then hundreds and hundreds of actions with hundreds and hundreds of views. So there's going to be a ton of duplication going on with all those views going on. So instead of us using the out-of-the-box stuff that comes with MVC core, instead of what we use is a library called HTML tags that provides a really cool way of building out, just like how our AutoMapper library builds convention-based mapping, HTML tags provides us with convention-based HTML building, just like we did on the back end. So what does that look like? Well, I've already pulled in the NuGet package, HTML tags.ASP.NET Core. So this is a version of the HTML tags library that's targeted, specifically built for ASP.NET Core. And in my startup, I'm going to go ahead and initialize it. So I'll do services.add HTML tags. There we are. OK, so as part of this, there's a few options that I will then add configuration to. But first, I want to go to my view to show you the kind of duplication I'm having to deal with. And the worst one I can see is probably the edit one. So in my edit view, I have this block of HTML that's copied, let's see, 1 time, 2 times, and 3 times. And this is just for a very simple form with 3 fields. If I have a form with like a dozen or 2 dozen fields, I'll have that same set of HTML copied over and over again. Now, I could use something like HTML helper extensions. People use HTML helper extensions before? The problem I see with HTML helper extensions is that they're all string-based. They're all dealing with string-based HTML content. Well, ASP.NET Core introduces the concept of tag helpers, which are basically fancy strings behind the scenes, and much harder, I found, to extend. So our teams took a look at tag helpers, tried to make them work the way we build forms, and found they weren't nearly as flexible as HTML tags. And HTML tags are object-based as opposed to string-based. What I mean by that is I can do something like var tag equals new HTML tag, passing in what kind of HTML tag it is. Do I want to add a class to it? There we go. Add a class. Fun time. Do I want to append HTML, add an attribute, all sorts of crazy stuff. So because my tag model, my HTML tag model is now object-based, I can now start to inject some smarts into how these HTML tags are built. So let me get rid of all this. OK, so I'm going to do some more copy-paste from my cheat sheet. Oh, I remember what I forgot. I didn't look at my cheat sheet for my validation example. Should have cheated. Cheaters always win. OK, so first, I'm going to modify my initialization just a little bit. And I'm going to be adding in these different convention classes. This default HTML conventions is what comes with HTML tags. It's all the HTML conventions for MVC applications. So the way to build input elements and Booleans being checkboxes, things like that, that comes from that base set of configuration there. And I'm going to add on top of it more conventions in this class right here. I'm just going to stick it right next to it because you can do inner classes. OK, so what I'm going to do is side by side slowly make changes to my tag configuration until it matches exactly what the existing editor does, and then go from there and make it even more smart, even smarter, even more smarter. OK, so back in my edit action, I've got this editor for blah, blah, blah. That's using, editor templates, which again are, anyone tried to make custom editor templates? It's like stupid hard to try to do that. It's ridiculous. So they're all Razor-based, and you can't do like really any actual code logic in there. It's just a kind of a nightmare to deal with. And so I can do this instead. So I'll do @html.input. Oh, before I do that, I'm going to go to my view imports and do @using HTML tags conventions, and I think just HTML tags as well. This is a new thing in MVC core to have global imports across all your views. That's what the view imports file does. You used to have to go to that web config file. That thing's gone. You use this thing instead. HTML.input. There we are. That was not there before. And I give it the expression for the model. So exactly what I have before input model.lastname. OK. Let's go ahead and run this and see what we see. All right, back over here, let me go ahead and click Edit. And we should see it look a little bit funny. But I've got this over here, and I got this is the new one, and this is the old one on the right. So it's already been able to do like the model binding stuff to put the correct piece in there. I don't have to worry about those pieces. Those are all coming from the integration with ASP.NET Core. Now, if I go look at the HTML, though, I will see some slight differences. Let's go and inspect this element, that one. And I see its input type equals text, value equals Alexander. This one, ooh, that's more. It's got like input class text box, single line, blah, 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 like a whole bunch of other stuff on top of that. So what I'll be doing is adding those extra conventions on top of it so that all that other information comes in as well. OK, so back in my startup, my configuration for my tags, I'm going to go ahead and add from my cheat sheet this right here. No. There we go. So this is saying that my editors will always add the class form control. Which I think is the old Bootstrap version, but that's OK. What did this have? Input class equals text dash box. Even though it's input type equals text, we have to be extra redundant here. So let's do that. Instead of form control, I'll have text. Now let's just leave form control. That's fine. OK, so refresh this page. And now, oh, it still has the old version of it. Oh, that's because it's an editor. OK, I'll get there in a second. The next one I want to add on top of it is my date times should always have this configuration associated with it. So oh, let me get rid of that pattern. I don't want that. Don't want that either. Those are some extensions that I don't actually want here. OK, and a short date string, does that not exist? Well, that's OK. We'll do toString. And which kind of string is it going to be? It's going to be the short date, that one. OK, so what this is saying is if it finds a property of type datetime, nullable datetime, is going to modify that by adding the date picker class on top of it. And then the value, if it has a value, is going to make sure it formats with a short date kind of format. So back in my view, if I now go replace this editor for with input, this one up here as well, we'll again see what we see. Okay, so if I go look at this element now, I remember what I forgot. I forgot to cheat again. Back in my startup, I forgot to actually add this convention to my list of libraries. So I need to actually do new MVC core HTML conventions. OK, so pulled in the default ones, and then adding on top of it are mine. OK, that makes me less confused now. All right, let's refresh this. And now we should see now all my conventions now. Oh, there we go. So now it's adding on top that form control bootstrap style that put the little rounded corners on top of it. The short date format here, which I'm sorry, on my laptop is month, day, year. Sorry. And putting all the appropriate styling on top of everything. And I can keep going with this. I can then go pull in all the view kind of conventions and label conventions as well. So let me pull those in here. And custom category of kind of tags, that's what this piece is here. I'm just going to paste it all in so I can show the final product, which is going to be my view. Oh, let's not do that one. OK. So all this configuration is for telling the HTML tag library, when you see this kind of request to build this kind of tag, modify it with this configuration here. So the policy about how to build HTML tags is in one spot in my application right here. And if I need to add on top of it additional ways of building HTML tags, again, it all goes back to here. I'm going to go take this one step further. In that, I'm going to create some HTML helper extensions to build out, and let's just put this at the root. Oh, helpers. There we go. Here we go. This one right here. And, oh no, that's not the one. That's ugly. OK. Ah, there we go. Should pull everything in. Oh, HTML helper. There we go. So now what I can do with this input block that is building out the surrounding HTML I had earlier, and this form block as well, I can now go back to my view and actually replace all of this with that HTML.form block. Nope, form block. Namespace is wrong. Let's do there we go. Just made something up. There we go. Form block. M goes to m.lastname. And I'll have two more of those, first name, first mid-name, and enrollment date. And that actually gets rid of all of this. And what I'm doing right now is just really building policies about how these different form tags should be shown. Oops. Oh, I'll just get rid of these display ones. That's fine. and making sure that whenever I want to display a form block on a page, it always goes to that one single spot. And because it's all object-based in the HTML tags, it makes it super easy to compose out those individual models. So let me refresh this, and it should look exactly the same. It's got the label, it's got the input element, the validation message is on the side, and because it's all based off objects, it makes it super easy for me to, in my extension method, compose up different sets of HTML tags with different information, pushing them all together into one single HTML tag to show to the end user. Is that cool or no? Okay. So that library is called HTML tags. It's plugged into ASP.NET Core, and I use the plugin to ASP.NET Core plus some conventions to define a single policy for how HTML tags should be displayed throughout the entirety of my application. No more arguments about use this date picker, use that date picker, oh, this label should be above it or behind it. Nope, we have a single policy in a single place. So that was solid ASP.NET Core. My name is Jimmy. You can find me on Twitter at @jbogard. Everything you'll see here, including the right working example, will be on github.com/jbogard. All this kind of topics I blog at Los Techies. And one of the things I'm doing is building a video course doing exactly this. If you're interested about that, go to that bit.ly link right there, and you can sign up for the video course that basically walks through exactly all of these things that we just went through. Thank you very much. I hope you enjoyed this and have a great rest of the conference.